I welcome you all for today's session of class. This is a foundation program in mathematics, and this course is presented for you by Vidhyalakshmi Senior Secondary School. I welcome you all for today's session of class. If you are a school going children and if you are studying class 7 and above, then definitely this course is for you and it is only for you. In this course we are going to study about a topic called as rational numbers in mathematics. This is actually for grade 7, but if you are a children studying above grade 7, then definitely this will be applicable for you also. Rational numbers. When we want to study about rational numbers, it would be good to introduce you about the concept called as real numbers, and later on we will go into the chapter called as rational numbers. Okay. So real numbers, you all know that what are called real numbers. So those numbers that which you know till today are all come under the category of real numbers. So what are all the numbers you know? Positive numbers, negative numbers, decimal numbers, fractions, maybe square root numbers, that is root 4, root 3, root 9, root 10. So though like that is the numbers which comes under square root. So all the numbers that you know till today, all the numbers that you learn today will come under the category called as real numbers. Okay. This real number set, okay, this real number set is actually classified into 5 classes. Okay, that is, it is not classified, actually it can be subcategorized, that is, it can be separated into subsets into 5, it can be subcategorized into 5 subsets. Okay. So what are those 5 subsets if you ask me? Then that 5 subsets are natural numbers, the first one, whole numbers, the second one, integers, rational numbers, and the fifth one is irrational numbers. Okay, fifth one is irrational numbers. So these are the 5 subcategories that which we can categorize the whole system of real numbers. In these 5 categories, we are having the fourth one, which is called as our topic, our selected topic, rational numbers. Okay. Let us study about this rational numbers in detail in this video, but before that I want to give you some introduction about this natural numbers, whole numbers, integers, and then later on we will move into the chapter called as rational numbers. Okay. Let us start now. Natural numbers, I think you all know about that. Natural numbers, because naturally you know that number, because right from lower class, that means right from the small little age, when you was at childhood, you used to count the objects starting from 1. If you are given some apples, then you will be start counting from 1 apple, 2 apple, 3 apple, 4 apple, 5, 6, 7, 8. So you will be start counting from 1 naturally. So that's why this is called as natural numbers, and the set of natural numbers will be starting from 1. Okay. 1, 2, 3, 4, 5, etc., etc., etc. It will go on endlessly. Okay. Then when you come for whole numbers, all the natural numbers will be included in the set of whole numbers, but you can see that one additional number is there in the set of whole numbers. What is that? Yes, yes, definitely it is 0. So 0 is the additional one number which is included in the set of whole numbers apart from all the natural numbers. So in other words, in other meaning, I can tell you that all the natural numbers are included in the set of whole numbers in addition with 0. Then the next category, that is the next category that we study is integers. So integers, when you take integers, they include positive natural numbers, negative natural numbers, that is plus 1, plus 2, plus 3. Positive natural numbers, it includes negative natural numbers also, minus 1, minus 2, minus 3, minus 4, and also 0 it includes. So integers includes all the positive numbers, positive natural numbers, and negative natural numbers along with 0. Okay. And finally we are coming to our topic, to the topic that which we are studying, actually the rational number. So what is a rational number? You can see that here. A rational number is a number which it can be expressed in the form of P by Q. So very important thing in rational number is that it is a number that which it can be expressed in the form of P by Q. So those numbers which it can be expressed in the form of P by Q will come under the category called as what? Yeah, rational numbers. Say if you want to, if you want some example, I can give you some example. 2 by 3 is a rational number because of that it is written in the form of P by Q. P by Q. So minus 3 by 7 plus 4 by 10, 9 by 12, minus 3 by 24, whatever it may be, 111 by minus 312, 444 by 336, whatever it may be. So 11 by 29, 32 by 44, it may have negative sign also, either in the denominator or also in the numerator. 22 by 0, 0 by 22. But one thing you have to notice here, of all the written numbers, only one number is actually not suitable here. What is that? It is 22 by 0. If you take any number, it cannot be divisible by 0. If you divide by 0, then the answer will be what? Yes, obviously infinite or otherwise undefined. So no any number is divisible by 0. So because of that, you can write in any way, but it is not allowed to write with the denominator 0. It is not allowed to write with the denominator 0. So that's why clearly in the definition it is highlighted here. Rational numbers are the numbers which are written or expressed in the form of P by Q with Q not equal to 0. That is, the denominator part is not equal to 0. The denominator part is not equal to 0. So except 0 we can put any number in the denominator. But numerator not worried about that. See, I have written here 0 by 22. 0 by 22 is acceptable. But 22 by 0 is not acceptable. Because of that, denominator cannot be 0. So you have to keep it in your remembrance that the denominator of any rational number cannot be 0. Cannot be 0. Okay. So I think you understand this definition. Numbers which can be expressed in the form of P by Q with P not equal to 0, with Q not equal to 0, and P and Q are integers. Integers means what? It may be positive, it may be negative, or it may be 0 also, but 0 cannot be given to denominator. Okay. So this is the simple explanation for rational number, and now we are going to study in detail about the topic rational numbers. So rational numbers, a detailed study. Okay. So as such we have studied, a definition is given here, the same definition what we have studied. Numbers which it can be expressed in the form of P by Q with Q not equal to 0 are called as rational numbers. Here the very important thing that you have to notice is what? Q not equal to 0, that you have to mention, and P and Q are integers. So that you have to mention along with that. So those numbers are called as rational numbers. The next symbol representation for rational number set. There is some particular symbol assigned for each and every set. If we take the set of natural numbers, it is represented by the letter N. If we take the set of what it is called as whole number, it is represented by the set by the letter called as W. If we take the set of what it is integers, then it is represented by the letter Z, unique letter Z. So by the same way, the set of rational numbers is also expressed by a letter, and it is Q. Why actually Q is used? Actually it is a reasonable representation. Why we are using Q, you know? Actually rational numbers, when you see any rational number, it will be in the form of p by q, isn't it? So this form of p by q is nothing but the form of quotient. It is said to be the form of quotient. So actually the letter q comes from the word quotient. Quotient, okay. And also you have to know another one more thing. We are calling it as rational numbers. No, that rational numbers, when you look at the first part of the word, then it tells us that it is a ratio. Also the name rational numbers comes from the term ratio. So those are actually the meaningful name for the representation of set, and the name rational number itself is a meaningful name, okay. Then next we are going to study few properties of rational numbers, okay. We are going to study few properties. Totally there are 8 properties coined here. In the first screen we will be studying first 4 properties, in the next screen we will study the next 4, okay. So you see that the first property tells us that every integer n can be written as a rational number in the form of n by 1. Yes, every integer n can be written in the form of rational number in the form of n by 1. See, integer I am taking 2 is an integer. I want to express this 2 as a rational number. Then what I am doing? I am expressing this as 2 by 1, because you know very well that 1 is a common divisor for any number. So any number can be expressed with the denominator 1. So because of that I can express it as 2 by 1. Actually 2, when we see it individually, it is an integer. But when you write like 2 by 1, what it becomes? It becomes a rational number. Do you understand? When you look at 2 is an integer, but when you express the same 2 as 2 by 1, it becomes a rational number. By the same way, if you take any integer, minus 3 I am taking, it is an integer. When I write like minus 3 by 1, becomes a rational number. 333 I am taking, it is an integer. When I write like 333 divided by 1, when I express in the form of 333 divided by 1, it becomes a rational number, okay. So any integer in general, if you take any integer n, and if you are expressing in the form of n by 1, then this will become a rational number. So what in other words we can tell that, see, in the first slide we saw that all the natural numbers are included in the set of whole numbers, 0 is the additional number. All the whole numbers are included in the set of integers, negative numbers are the additional numbers in the integers. And now I tell you, all the integers are included in the set of rational numbers, but along with the integers there are some other numbers, that is the fractional numbers are also included in the set of rational numbers, okay. I think you understand. For that I would like to come to the screen. You can see here the natural numbers are starting from 1, 2, 3, 4, 5. All these natural numbers are included in the set of whole numbers. Additionally 0 is there. And you can see that all these whole numbers are included in the set of integers, and additionally negative numbers are there apart from these whole numbers. When you come for rational numbers, I tell you all these integers are included in the set of rational numbers apart from rational numbers. All the integers are also included, because when you take minus 3, you can write like minus 3 by 1. When you take minus 2, we can write like minus 2 by 1. When you take minus 1, we can write like minus 2 by 1. So by the same way, all the numbers can be expressed in the form of p by q. So I can tell you that all the integers are included in the set of rational numbers. Okay, clear? Yes. Now we move on to the next property. Okay. So now you are clear about that all the integer, that is every integer, whether it is positive or negative or 0, it can be written in the form of what? N by 1, and because of that all the integers are included in the set of rational numbers. Then we shall move to the second property now. Okay, let us move to the second property. Every integer is a rational number, but every rational number is not an integer. Yes, definitely. If you take a rational number, for example, I take a rational number for you. I take a rational number for an example, 2 by 3 is a rational number. This can be called by rational number alone. This can be called by rational number. But whether it can you call this as an integer? No, it is not possible to call this by an integer. But see, when I take a number integer 3 I am taking, okay. So this 3 is called as an integer. But when I express the same integer in the form of 3 by 1, it can be called by, because of that this is in the form of p by q, it can be called by rational number. Okay, an integer can be called as a rational number. Okay, an integer can be called as a rational number, but not all the rational numbers can be called as an integer. Here you cannot use the word, for this you cannot use the word, integer, because it is a rational number and a rational number alone. Understand? Okay. So then now we are going to the fourth property. Every fraction is a rational number, but every rational number is not a fraction. This might be somewhat confusing you. I tell you clearly now. Every fraction is a rational number. First of all, let us study about the first statement. Okay. Every fraction is a rational number. This is the first statement. See, I am going to take a fraction 2 by 3. This is a rational number. Minus 2 by 3. This is also a rational number. Okay. Because both of them are written in the form of p by q. So because of that both are rational numbers only. Clear? But I tell you, so I want to highlight this 2 as, this is a rational number and this is also a rational number. Okay, both are called by rational numbers. Okay, now you agree with that. Next I tell you, 2 by 3 comes under fractions. This 2 by 3 comes under fraction. That is, this 2 by 3 can be called by fraction. But I tell you, this minus 2 by 3 cannot be called by fraction. This cannot be called by fraction. Why it cannot be called by fraction? Because of that there is one negative sign inside that. Negative sign inside that. So whenever a fraction, so this may be called as negative of a fraction. Negative of a fraction. So we cannot call it by fraction. So I think you can understand clearly that whenever there is negative sign in the quotient, okay, then it cannot be called by a fraction. Whenever a negative, because you have to understand that, see, I am having 3 by 4. The totally 4 parts we are having, in that totally 4 parts, we have to take 3 parts. So that is the meaning of this 3 by 4. So when I express like minus 3 by 4, in the total 4 parts available, you have to take or you have to choose minus 3 parts, means you cannot able to take that. It is meaningless actually. So that's why we are telling that these are not fractions. Those which are having negative sign in the numerator or negative sign in the denominator, does not comes under the category fractions. You have to understand that clearly. If you want to call it as a fraction, you may call it by negative fraction alone. Okay, negative fraction alone. So you have to clear that. So then if you have a question that by what name it has to be called, then by what name we have to give for that? If it is given like -3/4, then what is the name that has to be given to that? Then only name that we can given to that is rational number. So that's why the topic emerges. Okay. So because of that -3/4 cannot be called by fraction, we categorized this -3/4 into another category called as what? Rational numbers. Okay. I think now you understand that why this rational numbers topic arises. Right. So that is what the fourth property tells us. The third property tells us. Every fraction is a rational number, but every rational number is not a fraction. Every rational number is not a fraction. You can see that there is one example I have shown here. So this -2/3, because of that minus sign, it is just called by a rational number and it is not a fraction. Clear? Now we are moving into the fourth property, and the fourth property tells us, so it is nothing but the summary of this property. It tells us that the system of rational numbers include all the integers and fractions. So all the integers are included inside the rational number, and also all the fractions are included inside the rational numbers. So that is what it is. It tells us. Then next, moving to the fifth property. The next fifth property, you can see that the value of a rational number does not change if both the numerator and the denominator of a rational number is multiplied or divided by the same non-zero integer. So for to understand this property, let me take an example. I just take a rational number 2/7 I am taking. Okay. So this is actually the rational number in simplest form, that is in standard form. I am multiplying this rational number by 5 in the numerator and 5 in the denominator. So what I am getting? I am getting 10/35 I am getting. 10/35 I am getting. Okay. I can tell you that when you look at these two rational numbers, that one I have taken 2/7 and the one that I obtained after multiplication 10/35, they may be different in view, but I can tell you that those two rational numbers will have same value. Okay. So I can tell you that these two rational numbers, that is this 2/7 and this 10/35, will be equal in value. Okay, equal in value. For to understand that, I can take let me take one more example. See, 1/2 I am taking, and you all know that the value of this 1/2 is 0.5, and when I multiply this 1/2 by 3 in the numerator and 3 in the denominator, what I will be having? I will be having 3/6. I will be having 3/6. When you divide this 3/6 and the same 0.5 you will be getting. Okay. So the value of 1/2 is also 0.5 and the value of 3/6 also 0.5. So 1/2 and this 3/6 both are having the same value, 0.5. So because of that, only we tell that if you multiply a fraction or a rational number by the same value in the numerator and in the denominator, then the value of the rational expression, that is the value of the rational number, will not change. That is what the property describes us. And I can tell you one more thing here. See, 2/7 is the rational number that we have taken, and 10/35 is the rational number that we got after multiplication. Okay. Then what I can call these two? I can call these two rational numbers as equivalent rational numbers. These two are said to be equivalent. Okay, equivalent. These two are said to be equivalent rational numbers because 2/7 and 10/35 are equal in value, same in value, but visually they are different. So because of that we call it as equivalent rational numbers. Okay. So when you multiply a rational number by some integer in the numerator and in the denominator, same integer, then the given rational number will be converted into an equivalent rational number. Okay. Yes. Then I want to move to the next property. Okay. The next property tells us, yes, the next property you can see over the screen. Two or more rational numbers are called equivalent rational numbers if and only if they have same value. Yes, just before I was explaining you the same thing, equivalent rational numbers. Two or more rational numbers are said to be equivalent rational numbers even if they are having same value, if and only if they have the same value. Okay, then not much more explanation in this property, and I am moving to the seventh property. You can see here, all the terminating and non-terminating recurring decimal numbers, all the terminating decimal numbers and terminating recurring decimal numbers, non-terminating recurring decimal numbers, all the terminating and non-terminating recurring decimal numbers will come under rational numbers. Okay, will come under rational numbers. That is, for example, I can tell you, if you take 1 by 3, the decimal expansion of this will be 0.3333, etc., etc., etc. It will not come to an end. So that you see, so when I write this 1 by 3, I want to write like 0.3 bar. The 0.3 bar represents that that 3 is actually repeating, recurring. It does not comes to end. So such a rational number, such a decimal expansion, that is which does not comes to an end and recurring, is said to be under will be in the form of, will come under the fractional form will come under rational number. Okay. So that is what it is telling. All the terminating and non-terminating recurring decimal numbers or rational numbers will come under rational numbers. Then the next point you can see that, next property you can see that a rational number p by q with q not equal to 0 is said to be in standard form if p and q have no common factor other than 1. Yes. If a rational number, if I am writing like 10 by 15, I am writing a rational number, this is a rational number, but I tell you that this is not in standard form because of the 10 and 15 are having 5 as common factor. If I eliminate 5, that is if I make cancellation over here, 5 2s are 10 and 5 3s are 15 I will be getting, then what I am having? I am having 2 by 3. This 2 by 3 is said to be in standard form. Do you know why? There is no any other common factors between this numerator and denominator other than 1. So that's why this is said to be in standard form, but this is not. Okay, so what is standard form of a rational number? A rational number is said to be in the standard form if and only if they have 1 as the common factor in numerator and in denominator. Okay, so these are the 8 properties that governs. These are the 8 general properties that governs about the rational number. And then next, see, 2 rational numbers p by q and r by s are said to be equal. 2 rational numbers p by q and r by s are said to be equal if and only if p multiplied by s is equal to r multiplied by q. Okay, when you make cross multiplication here, it will become p multiplied by s, and when you multiply here, it will become q multiplied by r. Okay, so this relation has to be satisfied. So p multiplied by s and q multiplied by r must be equal for the given 2 rational numbers to be equal. Okay. Yes, then next we are going to study some specific properties in the case of rational numbers related to arithmetic operations. Okay. You can see that there are 6 properties which are related to arithmetic operations on rational numbers. One is said to be closure property, the second one is commutative property, the third one is associative property, fourth one is identity, fifth one is inverse, and the sixth one is distributive property. So these are the 6 properties that a rational number may obey or may not obey. It depends upon the nature of operation that we are using. When you are taking arithmetic operation, we may have addition, we may have subtraction, or we may have multiplication, or we may have division. So depending upon the operation, a rational number may obey any of the rule or may not obey any of the rule depending upon the operation that you are choosing. Okay. So that we are going to have a detailed study. In the next screen you can see that properties of arithmetic operations on rational numbers. These are the 5 properties already I told you: closure property, commutative property, associative property, identity property, inverse, and distributive property. Okay. First I want to discuss for addition and multiplication, because you can see that for addition and multiplication, closure property, commutative property, associative, identity, inverse, and distributive all are satisfied. Because of that, this screen is actually appearing green, which means that these properties are satisfied for all the rational numbers. Okay. So when you take any rational number, it will obey all the 6 properties with respect to addition and multiplication. Okay. Remember that. But only one thing you have to notice here: distributive property is not applicable in the case of addition, because we cannot be able to distribute addition. Okay, we cannot be able to distribute addition, because you can see that when you look at this formula, you can able to understand that why it is not applicable in the case of distributive property in the case of addition. Okay. First of all, I want to start explaining you from closure property. What does simply I want to tell you what does this closure property tells us. A by b is a rational number and c by d is a rational number. If you are adding these two and we have to get and we will be getting some other number, no. So that must be also in the form of e by f. That is, it must be a rational number. Then only we can tell that closure property is satisfied. But for addition, it will satisfy. By the same way, when we come for multiplication, a by b into c by d. There are 2 rational numbers, a by b, another one is c by d. We are multiplying and getting another number, another rational number in the form of e by f. Okay. Then it is said to be that the closure property is satisfied with respect to multiplication. Then commutative property, you can see that 2 rational numbers are chosen here, a by b, c by d. How it is related here? C by d plus a by b. You can see that the order is reversed. Okay. Whenever you are studying about commutative property, you have to remember that the order is reversed. 2 expressions will be equal irrespective of their order. So this is the general explanation I can give it for commutative property. Here, with respect to multiplication also, you can see that a by b into c by d must be equal to c by d into a by b. Then only it is said to be that it is commutative under multiplication, but you can see that rational numbers are commutative. It would be definitely equal. Okay. Then associative property, you have to understand that we are taking 3 rational numbers here, a by b, c by d, e by f. The same a by b, c by d, e by f we are having, but the order is different. Order of association is different. Order of grouping is different. Okay. See, you can here c by d and e by f are associated, whereas a by b is outside. Now a by b is associated with c by d, whereas e by f is outside. Do you understand? So here the order is different. Order of grouping is different. And by the same way for multiplication we are having here. Okay. Then identity property. In the case of identity property, it is not just a property. It is that we need to find an element in the set of rational numbers, such that element a by b, because rational numbers will be in the form of p by q, no. So a by b plus something, here I have written like 0, but something we have to add here. And also when you add in the reverse order, that is that some number when added with this a by b, we have to get the same a by b. See, for example, I am taking 2 by 3, okay. With 2 by 3, what you will be adding for to get the same 2 by 3? 0. 0 plus anything, you will be getting the same thing. So, that 0 is called as the additive identity. Additive identity. Because of that, the operation we followed is addition, no? So, that is why the 0 is called as additive identity. But in the case of multiplication, the same 2 by 3, you just choose it. What you have to multiply with this 2 by 3 for to get the same 2 by 3? 2 by 3 into 1 gives 2 by 3. Am I right? So, what you are multiplying with that number, that rational number, with 2 by 3 you are multiplying 1. So, that 1 is called as identity in the case of multiplication. So, 1 is called as multiplicative identity. So, you can see here 1 is the multiplicative identity. In any order, it gives the same number a by b. Here also, in any order, it gives the same number a by b when you add the 0, and here when you multiply this 1. 0 is called as additive identity and 1 is called as multiplicative identity. You have to remember, again I am telling you have to remember. Okay. Then coming to the property of inverse. Inverse, we are having two inverse. We are going to discuss about two inverses. One is additive inverse and by the same way multiplicative inverse. Additive inverse is nothing but we are taking a rational number. With that rational number we are going to add, we don't know what we need to add here, I just hide it. But what is the result that we have to get, you know? This identity element you have to get. That is, you are taking a by b, the rational number. With a by b, what you need to add so as to get 0? Because 0 is additive identity. You have to add minus a by b. If you are taking 2 by 3, minus 2 by 3 we have to add. When we are taking minus 2 by 3, we have to add plus 2 by 3. When we are taking 1 by 3, we have to add minus 1 by 3 so as to get 0. When we take p by q, we have to add minus p by q. Any number you just take, if you take any number and the additive inverse is nothing but the negative of the given number. That is the number with opposite sign. If you are taking 2, then minus 2. If you are taking minus 2, then plus 2 is the additive inverse. Understand? So, for individually each and every element, there will be a additive inverse. But for all the elements, you will be having the same identity. In the case of multiplication, separate, but in the case of addition, separately you will be having, and also in the case of multiplication you will be having separately. So, the identity element differs only because of the operation, but the inverse element differs number to number and also operation to operation. When you come for this case, that is in the case of multiplication, we are having a number a by b, and you see that the 1 is the identity, multiplicative identity. This one we have to get at last as the result. So, which number you have to multiply here? Which number you have to multiply here? b by a. When you multiply b by a with a by b, you will be getting 1. Okay. So, b by a is what? It is the reciprocal of a by b. So, in the case of multiplication, the multiplicative inverse will be the reciprocal of the given number. If the given number is 1 by 33, 33 by 1, multiplicative inverse. If the given number is 44 by 9, 9 by 44, multiplicative inverse. If the given number is 100 by 21, 21 by 100. If the given number is minus 333 by 4, you will be having 4 by minus 333. In this you should not change the sign. You have to make just reciprocal. Clear? Okay. Now, coming for distributive property, it is not applicable in the case of addition, but it is applicable in the case of multiplication. You can see that we are taking three rational numbers, a by b, c by d, e by f. A by B is multiplied with these two addends. These are said to be addends, C by D and E by F, because of that they are in addition. Okay. Now this A by B can be distributed, that is, it can be multiplied over the C by D, that is A by B into C by D. We are having plus here, so the same plus we have to carry. Then this A by B is distributed or multiplied with E by F, A by B into E by F. If this relation gets satisfied for any three rational numbers, then we tell that the rational numbers is distributive over addition. Obviously, it will satisfy the property. Definitely, it will satisfy the property if you take any rational number. Okay, then in the case of subtraction, here we are having minus, no? So, because of that, this is called as distributive property of multiplication over subtraction, whereas this is called as distributive property of multiplication over addition. Okay, there are two distributive properties. One is distributive property of multiplication over addition. Here distributive property of multiplication over subtraction. Okay, so the same thing, A by B into C by D minus A by B into E by F, minus A by B into E by F. I think you will understand that what this tells us, but it is not applicable in the case of addition. It would not be equal, and it is meaningless in writing such a distribution. Addition is not distributive. Addition cannot be distributed. Okay. So the next we are going to the next screen. Yes. In the case of subtraction and division, you can see that this alone is given in green color. Because of that, it will satisfy this two property, and whereas commutative property will not be satisfied for subtraction and also for division. Associative property will not be satisfied. Identity property will not be satisfied. That means will not be satisfied, it means in the sense it is not applicable. There is no any meaning of writing it. Inverse property will not be satisfied. That is not applicable. Distributive property is not applicable. So, in the case of subtraction, only one property that it holds good is the closure property, whereas the rest of the properties will not be applicable, and it will not be equal in the case of rational numbers. You have to remember. Okay. Then next we are going to have a small recap over that what we studied. Okay, first I want to write what are all the properties get satisfied in the case of addition and multiplication, because it is easy. Closure property, yes, it is satisfied. Commutative property, yes, addition, all are satisfied. But you know, identity element is in the case of addition 0, and inverse element in the case of addition minus A by B, that is the number with opposite sign. Distributive property not applicable, not applicable. Then coming for multiplication, all are satisfied, all are satisfied. Even there is distributive property of multiplication over addition. So all are satisfied in the case of multiplication. But for subtraction, only closure property, and also for division, closure property alone satisfied, whereas commutative and associative property definitely will not be satisfied. So I want to write these two properties will not be satisfied in the case of subtraction and division. Then next, identity, it is not applicable, and here also not applicable, here also not applicable. It is not applicable. Okay. And another one more thing I forget to write here, it is that what is the identity element in the case of multiplication? 1. What is the inverse element in the case of multiplication? B by A, reciprocal. So this is actually a short revision about the properties in the case of arithmetic operations about rational numbers. Understand? So these are the things that you have to remember. The next, the same thing is given clearly here. Closure property is closed, commutative, associative, identity element is 0, inverse element is minus A by B. This is not applicable. Whereas multiplication, closed, commutative, associative, identity is 1, inverse is B by A, distributive over addition and subtraction. Whereas you can see that the same thing that what we studied, we are having here. Okay. Okay. So with this, the introduction part for in the case of rational numbers comes to end, and in the upcoming video classes, in each and every video module, we will be solving 5 questions from the chapter of rational numbers, and you just make use of each and every video. In each and every video module, you will be given a link in the description area. Using that link, you can go into a study material for each of the video, and you can make use of it. And also some assignment work will be given. That assignment work you have to practice at your home, and you can make use of it, and you can able to be a better hero in mathematics. Okay. So continuously follow our class and subscribe to our channel. Please share our video for others can be benefited, and also like the video, and please give your comments, valuable comments, because a positive comment, not only positive comment, even negative comments, because it would be helpful for us to give better video in the upcoming classes. Okay. And finally, I want to tell you, thank you and God bless you. Bye bye.